Welcome you all to my video. We are going to discuss chemical kinetics. Mainly, I focus on the things which will be affect for the reaction rate. So there are main four things we have to consider about the rate of the reaction. There are four things. The first one is physical state. Physical state of reactants. Second thing is concentration. The third one is temperature. The fourth one is going to be catalyst. So these are the major four things we have to consider when we are discussing about the chemical kinetics. There are four major things: physical state, concentration of reactants, everything is reactants, physical state, concentration, temperature, and catalyst. Catalysts are not reactants. Catalysts are not reactors. Remember that. Okay. Step by step, I will discuss these four things. First one is physical state. In short, in very briefly, I will explain what is physical state. We know the matter is appear as solids, liquids, and gases. Solids, liquids, and gases. So these are the major states of matter. However, when we talk about the state of physical state of reactants, here we mainly focus on the reactants, whether they are in same phase or different phases. For example, if we mix two miscible liquids, imagine there are two reactants, both are in liquid form, A and B. A and B. We want to react both of these reactants. So imagine A is in a different phase and B is in a different phase. They are not miscible. So here, upper layer, imagine upper layer is A, the lower layer is B. And another thing I will draw, another beaker. There are two things we want to react each other, P and Q. P and Q, they react each other. So those are visible now. I just give symbols, plus mark for P and negative mark for Q. So here, what can you say about this? What can you say? As the appearance, what can you say? Both P and Q are miscible. They are in same phase. So what is the conclusion? If you observe very carefully, in this situation, number one situation, what will happen? Those are well mixed. Well mixed. So, what is the meaning of that? In this situation, we have to talk about another subtopic the theory of collision. Theory of collision. So, what is collision? Two molecules split each other. They collide each other. So, imagine this is P and this is Q. Both are reactants. In this solution, they are visible. When mixed, they are visible. So, both reactants can interfere each other very well. So, they collide each other because they are well mixed. So, here, the reaction is happening very fast. Why is that? They are in same phase. If the reactants are in same phase, the reaction is proceed very well. So reaction rate will be higher. On the other hand, what can you say about this? Number 2. They are in two phases. They meet each other at one interface. This is the interface. So in this interface only they will meet each other. So reaction is limited to this interface. What about this? On the other hand, there is no one interface. So many directions, so many reactants react each other. They collide each other very well because they are visible. But on the other hand, in this situation, there are so many reactants in upper layer and there are so many reactants in lower layer. But it is pointless because they can't react very well because they have only one interface. Reaction is going on only in this interface. Here, the reaction rate is low compared to this number 1 solution. They are visible one phase, and these two are in two phases. So their reaction rate is low. In this situation, number 1, its reaction rate is very well, very higher. So that is the first thing we can say about the physical state. On the other hand, there is another thing we have to consider: the area of the reactor. For example, if you want to get to make a quick fire, what would you do? What is the method? You have some woods or branches. There are big branches of wood, and there are some small wood parts or branches. How can you initiate the fire? To initiate the fire, you will use smaller particles, no? Small. Because what is that? In smaller particles, so smaller woods or branches. What about the surface area? Surface area is very high. Surface area is very high compared to this large parts of the wood or branches. So we use always small woods or branches to initiate the fire. After initiating, we add larger particles, larger woods. Likewise, the reaction rate of a reaction will increase with their area also, surface area also. With the increasing surface area of the reactor. Okay, that means we have to use smaller particle. Particle size of reactant should not should is must very low. If we get larger particle, their surface area given in this cube, and if we divide this cube into small cubes, we get another 1, 2, 3, 4, 8. We can get 8 small cubes if we divide them into equal halves, 2 equal halves, and perpendicular and other axis. So we can get 8 small cubes from this large cube. So the surface area will increase. Surface area will increase after dividing these larger molecules, larger reactants into small reactors. So we have to increase the surface area before starting the reactions. So some reactions we use zinc brings to some reactions. In some phytochemical reactions, I will discuss in one day. However, some metallic, we use some metal particles to catalyze a reaction. To catalyze the reaction. So if we use, imagine this is zinc. Instead of using zinc springs, we can use zinc dust. That is small particle. Same thing, we powder and we get zinc dust. If we apply zinc dust instead of large zinc particles, we can achieve a higher reaction rate. The things we have to remember in this physical state lesson, there are two conclusions. First one is reactants must not must actually, they may be in two phases, but reactants, if the reactants are in same physical state, if the reactants are in same physical state, that means actually same phase, I mean same phase. The reaction rate will be higher. Second thing is the area, surface area. If the surface area is high in reactants, again the rate of the reaction will be higher. And vice versa, is possible if the reactants are in different phases, the rate of the reaction will be lower or decrease. If the surface area is minimum, sorry, if the surface area is just surface area is lower, the reaction rate also lower. That's the first thing related to the physical state. Let's move on to second title very quickly. The first thing, the second thing is concentration. As I said previously, concentration. So, what is the concentration? Concentration given by equation C equal N over V. N is number of moles. V mean volume in cubic decimeters. So your answer will be moles per cubic decimeter. Another theory, but here I'm going to say the N moles. Moles mean number of moles is equal to the mass in grams divided by the molar mass of a particular molecule or atom. That's not the theory I'm going to explain. Here, concentration is which is effect for the reaction rate. The number of moles or N is related to the number of atoms or number of molecules or number of reactants. What is the relationship between moles and number of atoms or molecules? That is the equation. Number of molecules is equal to number of moles into Avogadro constant. By using this equation, we can get number of atoms in a particular mole amount. So the conclusion is N is directly proportional to capital N. That means, let's imagine we have a solution in a particular volume. This is the 2D structure of a cube. Just imagine its volume is V. There are 4 particles or 4 moles, N equal 4. Just forget the N. I will because N is proportional to the capital N number of atoms or number of molecules. Here moles. Number of moles are proportional to number of reactants or atoms or molecules in this situation in chemical kinetics. So here there are 4 reactants. So its concentration will be, let's imagine there are 4 atoms in same volume, in volume V. This is the same volume, but I will introduce another 4 atoms or another 4 molecules into this solution. Now the number of molecules or number of atoms or number of reactants are 8. Here it is 4, here it is 8. Now what can you say about the concentration? Concentration of this second situation, this second situation is 8 atoms in the same volume. We didn't change the volume. It is the same volume, in these two situations, but we increase the number of atoms. Here 4, here 8. What about the concentration? The upper part of this equation is increased. Here it is 4, here it is 8. So number of the concentration is increased. So what I wanted to say, if we increase the number of atoms or number of participants or number of reactants, concentration will increase. So what is the relationship between concentration reaction rate? Okay, to explain that, imagine this is a reaction. What we consider to explain this theory. Reacting A and B, they will give us products. So imagine this is the A molecule or atom. This is B. In this first situation, in this cube, imagine the distance between two reactors is this. We call this distance collision, pre-collision path. This path. To give the products, these two reactants have to come together. So they have to cross this path. They have to come to each other on this path. This path is pre-collision path. When the concentration is low, the reactants molecules or reactants are in some distance. They are in some considerable distance apart from each other. Imagine this length is L1. Because their concentration is low, so they are distributed very freely. So the distance between these two reactants is very large. What about the second situation? This is first situation. What about the second situation? In second situation, concentration is very high, but the volume is same. So here space is very high. Free space is very high in this first situation. Why? Very low number of molecules or reactants are here compared to second situation. In second situation, same volume is occupied by more atoms, more molecules, or more reactants. So the free space is limited compared to first one. So by considering that, we can imagine the pre-collision path of this second situation. What will be that? What are their lengths? Length among two reactants will be higher or low. What can you say? Here number of atoms or molecules are very low, so they can distribute very freely. So the distance among them is somewhat large. But if we increase the concentration or number of atoms or molecules or reactants in the second situation within the same volume, their free space is becoming limited. So they come very close to each other because the free space is limited because the number of atoms or number of reactants is increased within the same volume. So their concentration is high. That means they come close each other. Their free collision path is L2 is decreased. So that means L1 is larger than L2. If we continuously increase the concentration, the free collision path length is keep decreasing. So What is the meaning of that? When the path length is decreased, they come close together, closer to each other. That means they can react easily. In first situation, the distance between two reactants is very high. To react them, they have to come close each other. So it gets some time because the distance is very high. But compared to that situation, in second situation, the distance in between them is very low. Because of that, they have come very short distance. So they can react easily than the first situation. So if we increase the concentration, what about the reaction rate? If they react easily, the reaction rate will be increased. So here the reaction rate increase. Sorry. In first situation, reaction rate is imagine I had only one arrowhead. In second situation, I put two arrowheads. So their reaction rate is very high. So if we increase the concentration, rate also will be increased. They are proportional, directly proportional to reaction rate. Okay, why is it happening? If I explain it another way, in another way, to react to the species A and B, two reactants, to happen a reaction, they have to collide. They have to collide. When we increase in the concentration, the colliding rate, collisions, number of collisions will be increased. So collisions will be increased. They collide each other very well by increasing concentration. That's why the reaction rate is increased. Okay. This is in this example we talk about this liquid aqueous phase. So define aqueous liquid. These atoms we dissolve in some water, ethanol, or some liquid media. However, what about the gas phase? If the reaction is going on the gas phase, when we talk about gas, we do not talk about concentration very well, very much, because in gas phase we are talking about pressure. Imagine there are some gaseous reactants. If we increase concentration, probably that will be increase the reaction rate. But in gas phases, we will focus on the pressure than the concentration. If we increase the pressure, what will happen in a gas phase? If we increase the pressure, the reactants will react very fastly because of their motion will be higher. If we increase the pressure, again reaction rate will be increased. That is in the gas phase. So that's the thing. In liquid, in aqueous or liquid media, we have to consider about the concentration. In gas phase, we focus on the pressure. If the pressure increases, the reaction rate also increases. So let's move to our third title, which is effect for the reaction rate. What is that? That is the temperature. Temperature. What about that? Liquid or gas, anything. Imagine these are reactants. If we increase the temperature, what will happen? What will happen if we increase the temperature? If we increase the temperature, the speed of the reactants or molecule, speed, what will happen? When we heat, a balloon, it will uh, so here I want to tell if we increase the temperature, speed of reactants increase the reactants will be high. Why is that? What is the reason for that? If we provide temperature, that means we give energy. Energy. Not just energy, it's kinetic energy. Kinetic energy or kinetic energy. If we increase the temperature, kinetic energy of these molecules will be increased. So what will happen if the kinetic energy increases? What will happen? Just imagine what did you learn in your science classes, in your colleges. What will happen? If we increase kinetic energy, the reactants will reach to their what? There is energy gap. Likewise, what is this? Kinetic energy. What is that? Another name? Activation energy. They will reach to their activation energy. So reaction will happen. So reaction rate will increase. Why is that? On the other hand, if we increase temperature, the thermal motions will help to reactants to come closer to each other. Together, their kinetic energy will be increased. So the velocity or speed of these reactants will be high. They collide each other very fastly. So reaction rate will be very high. So that is the thing you have to know in this title according to the temperature. If we increase the temperature, the speed of the reaction will be increased because the kinetic energy of the reactants will be increased. So the reactants will reach to their activation energy. So the reaction rate will be increased. So those are the things you have to know regarding to temperature. Okay. The fourth thing, the final thing I am going to discuss today is catalyst. Catalyst. What is the function of catalyst? They provide different reaction mechanism for the reaction. Why is that? Imagine the energy potential energy reaction. Here, imagine this is our reactants. Here, this is the product. This is the reactants energy. Sometimes the products will be here about the energy of the reactants or below. Doesn't matter. To get product, the reactants must go through a maximum. This is this. Doesn't matter. We will select only one. That will be easy. Here, this is the energy of reactants. This is the energy of product. What is this? In this type of diagram, the maximum is always represent a transition state. In this transition state, some bonds are breaking and some bonds are forming. The transition state. So reactants must go through a transition state to produce product. So the energy gap between transition state and the product reactant is called the activation energy. Activation energy. If we introduce the catalyst, what will happen? They will give different reaction mechanisms. They will provide different reaction mechanisms for this reaction with low activation energy. So they decrease the activation energy. Here in the first situation, the activation energy without catalyst, the activation energy is here. I will tell you that E1. After providing a catalyst, the activation energy will be lower. They will use same product with the low activation energy. Here, this activation energy EC, AC, A catalyst. So they decrease activation energy by this amount, delta E milliliter catalyst. So now the reactants can produce products very easily than the first part. This is one part. The catalyst given us another easy path for this reaction. So that's the thing we have to know about this catalyst. So when we talk about catalyst, there are so many type of catalyst we have to study. Some are auto catalyst, some are heterogeneous catalyst, some are homogeneous catalyst, some are biocatalyst. So I will explain them in another video. However, you have to know the thing you have to know is catalysts provide and different reaction mechanism which have low activation energy. So reactants will react very easily than the situation which have no catalyst. So with the catalyst, the reactants, more reactants will react each other than the without situation. So here, this activation is very low. So catalyst will decrease activation energy. So the reaction rate will be very high in this situation. So another video, I will explain the four types of catalysts. In this video, I focus on major things will affect for the reaction rate. So in briefly, first one was first one we discussed physical state. First one was physical state. Second one was concentration. Third one was temperature, and fourth one is the catalyst. In briefly, uh, what happened in physical states? What we discussed. Two things we discussed. First one is the reactants should in same phase to happen a proper reaction. Not should actually. There may be in separate phases, but if they are in same phase, the reaction rate will be high because number of collisions will be higher. So many orientations they can react each other. If we have two phases, they will react only in the from the interface only. Other thing is the surface area of the reactant. If we increase the surface area by decreasing the particle sizes, the reaction rate will be increased. Second one is concentration. Concentration means number of reactants within the same volume. If we increase the number of atoms or molecules or reactants in the same volume, what will happen? The free collision path length will be decreased. Because of that, the reactants may come close together each other than the previous situation, and they will readily react each other very well. So the reaction rate will be higher when we increase the concentration. On the other hand, in gas phases, we talk about pressure. When we increase the pressure, when we increase the pressure, the reaction rate again will increase in gas phase. Next, we talk about temperature. When we increase the temperature, the kinetic energy of reactants will be increased. When kinetic energy increases, the collisions will be increased. They collide each other very well because their kinetic energy and their speed is very higher. So, because of this higher kinetic energy, their activation energy will be low. Activation energy also not low. Sorry. When kinetic energy higher, the reactants will reach their activation energy. So many collisions will happen and the reaction rate will be increased. When we use catalyst, at that situation, the catalyst will provide another mechanism for the reaction with low activation energy. We have to provide small energy than the situation which wasn't contain any catalyst. So with the catalyst, they provide another reaction mechanism with low activation. That's why reaction speed or reaction rate will be. So that is the conclusion. There are so many types of catalysts. I will explain them in another video. And small request I have, please subscribe my YouTube channel and help me to help you.